Good afternoon, everyone. I'm BRYAN, ALESNA, a Geotechnical and Research Development Engineer of APEC Industries for Composite Polymeric Materials, LLC. Today, we'll be discussing about drainage, geo-composite, and roads and pavements, its principles, performance, and practical applications. So water management has always been a critical factor in the long-term performance of roads and pavements. In this presentation, we will examine why drainage is so important, the limitations of conventional drainage systems, and how drainage geocomposites provide an efficient and modern solution in improving the pavement durability and service life. So, water is essential for human life, ecosystem, and economic development. However, in transportation, uncontrolled water can become one of the most destructive elements. Roads are continuously exposed to rainfall, differences in groundwater elevation, seepage, and capillary rise. So when this is not managed, it changes the engineering properties of the soil and aggregates. Therefore, in pavement engineering, water itself is not the problem, but the real challenge is the uncontrolled water accumulation, which can significantly reduce the water pavement performance. So, poor drainage and excess moisture results in weakened subgrade, reduced pavement performance, lowering bearing capacity, and shorter service life for the roads. As the subgrade becomes saturated, the strength decreases considerably in making the pavement more vulnerable to traffic loadings. Consequently, owners and agencies face increased maintenance cost and reduced reliability of the transportation infrastructure. Traditionally, this has been mitigated using an open-graded drainage layer. So this consists of a thick coarse aggregate placed beneath the pavement and connected to the edge drain. The concept is very straightforward. Water infiltrates to the pavement, reaches to the aggregate layer, and then removed by gravity. Although the approach has been widely used, practical experience have identified several limitations on this approach. So one major limitation is that these open-graded drainage layers generally function effectively only when there is sufficient saturation that has occurred. So unfortunately, by this time, moisture has already or may have already damaged the pavement structure. So the ODGL system can also suffer by clogging of fines, retained moisture because of the hydrophilic structure or nature of the aggregates, and often requires large quantities of aggregates and sufficient excavation for maintenance and rehabilitation. So these limitations have encouraged engineers to seek more efficient drainage alternatives. And one of these alternatives is by using drainage geocomposites or geosynthetics. So geosynthetics have already been there in the market since 1950s and accelerated through 1970s and 80s. So initially, this has been used as erosion control and filtration. And soon, geosynthetics has become an essential component in roads, embankments, retaining structures, and drainage systems. So its popularity is due to the lightweight nature, factory-controlled properties, ease of installation, and ability to perform specific engineering functions. So among these products is the drainage geocomposites. So what is a drainage geocomposite or a geosynthetic capillary drain? This is an engineered geosynthetic product designed to collect, transmit, and remove water while simultaneously separating and protecting adjacent materials. So as you can see in the figure, it generally consists of three components: a transportation or filtration layer, a drainage core, and a separation or protection geotextile. Essentially, it combines multiple functions into one thin engineered system. So the first component is the filtration layer. Usually is a geotextile, which allows water entry while preventing soil intrusion. The second is the drainage core, which provides the in-plane flow path for the water movement. And the third is the separation or protection layer, which protects the core and prevents any clogging in the system itself. Together, these components provide an efficient drainage performance while maintaining the long-term durability or stability of the pavement. So how it works? It is basically simple. Water infiltrates again to the pavement, reaches to the geotextiles and enters to the drainage core, and then transmits laterally to the edge drains and outlets. An important advantage is that properly designed geocomposite can begin draining water even before positive pore water pressure develops. So unlike the conventional system where you need a full saturation, the drainage composites can drain water while soil remains unsaturated. This reduces the subgrade wetting, limits capillary rise, and improves moisture management before significant damage occurs. This process prevents moisture accumulation within the pavement layers and is particularly valuable in moisture-sensitive pavements, especially here in the UAE. So there are three common types of geocomposites. So mainly, or firstly, the 3D monofilament geomat composite, which is a flexible and widely used product here in the UAE. Second is a cuspated sheet, composed of a dimpled sheet commonly used in retaining walls and foundations. And the third is a geonet composite, which provides a high in-plane flow capacity. The selection of which product or which type of geocomposite depends mainly on the loading conditions, required transmissivity, and site requirements. So design of drainage geocomposites is supported by several international references. This includes ISO Technical Report 18228-4, which is the design of geocomposites for drainage application. Geosynthetic Research Institute publications, ASTM STP 1390, the FHWA guidelines, and also International Geosynthetic Society publications. There are also local guidelines, such as ADQCC specifications, that have introduced drainage geocomposites in their specification. So these documents provide guidelines on testing, design, installation, and performance evaluation of the drainage geocomposites. So the performance of these materials depends on several design parameters. So this includes transmissivity, compressive strength, creep resistance, filtration compatibility, flow at different hydraulic gradients, and installation survivability. So long-term performance under confinement is especially important because drainage capacity of these materials can change significantly under sustained loads. Therefore, a proper design should always be considered and should always consider the actual field condition rather than the technical parameters of the material itself. So the key advantage of having this drainage geocomposite is that the conventional drainage layers usually requires at least 300 mm of these thick aggregates, while the drainage geocomposites may only need at least 6 mm of this thickness to provide the same equivalent drainage performance. So this significantly reduces the excavation requirement for cut pavements, material transportation, construction time, and environmental impact of the project. So it's still, this drainage geocomposite still needs to be properly connected to a drainage system. So the collection should be on the edge drain or a collection pipe. So there is a proper requirement for the proper installation of these drainage geocomposites, as failures may include clogged head walls, crushed pipes, and poor outlet detailings. Therefore, installation quality and construction supervision is equally important as to the product selection itself. So drainage geocomposites have numerous advantages. They are lightweight, easy to install, and requires less construction space, since they are factory produced and delivered to site on roll forms. They can significantly reduce the moisture accumulation and shorten drainage time in the pavement. Many projects have recorded a cost savings of 40 to 60% compared to open-graded gravels. So additionally, they provide a consistent factory-controlled properties and are particularly beneficial in in areas where quality aggregate is scarce. So despite these advantages, drainage composites are not a universal solution. So not all products are suitable for all applications. So long-term creep, confinement effects, filtration compatibility, and installation quality must carefully be evaluated. Regular maintenance and outlet remains a crucial part of the effectivity of these drainage composites. So success performance ultimately depends on proper design of these geocomposites and the proper construction practices used during construction. So the use of drainage geocomposites extends not just on roads, but also in railway application, beneath ballast beds and slopes, in tunnel walls between concrete lining and shotcrete surfaces, so behind retaining walls, on landfills and ponds, green roofs, plaza decks, sports field, truck drainage, and landscapes. So the broad range of application demonstrates the versatility and effectiveness of the technology. So some case studies that we have worked on with the use of drainage geocomposites. So we have proposed one application on the pavement in one of the Abu Dhabi Island projects. So we have been approached by the client to find alternatives for these open-graded gravels. And after careful assessment by the use of the proposed 3D monofilament geocomposite, specifically the product grade MatFlow 2830, it is found that it can fully replace the 300 mm gravel drain while providing an estimated cost savings of 59% and material savings of 53%. Furthermore, the use of 3D monofilament geocomposites can provide 97% reduction in carbon emission for the project. So on another project, we have also provided cuspated sheets for a tunnel project in Fujairah, where we have installed the drainage composite between shotcrete and concrete lining in the high seepage areas of the tunnel. So one application is in Dubai Creek Harbor, where hardscapes and pavements have constantly experienced discoloration, efflorescence, and durability concerns due to capillary rise and seepage from adjacent planters. So APEC Industries have provided an engineering solution using 3D monofilament geocomposites under the interlocking pavers and providing the required capillary break and drainage for the system. So this in turn is connected to a drainage system, and in addition, an additional impermeable root barrier has been installed in the areas adjacent to the planters to prevent seepage from irrigation. So water is one of the primary causes of pavement deterioration. So conventional drainage system sometimes is always being considered here in the UAE, but there are certain limitations that it needs to be addressed too. So drainage composites provides an alternative that is efficient and provides practical, efficient, and high performance solution for the pavement drainage. So they improve moisture management, accelerate drainage, and enhance constructability, and can significantly reduce cost and environmental impacts for the projects. Most importantly, drainage geocomposite should be viewed not merely as a replacement of aggregates, but as an engineered hydraulic system that can significantly improve pavement performance. And as we strive to be more sustainable and durable in our projects, drainage geocomposite should be seriously considered as a preferred drainage strategy, particularly on weak and moisture-sensitive pavements. Thank you very much for your time and attention.
Thank you, BRYAN. Great applications here. We show it. We can take questions.
Thank you for the presentation. This is Dr. Rosuddin from American University of Ras Al Khaimah. Given that this product has some sort of durability and it's cost effective as well and sustainable, what would be its durability in areas where it is required to be laid in aggressive soils? For example, where their sulfate content is high, how durable this material will be. Second question relates to, given that these days the lot of highway pavements are designed and constructed for longer service life. What is the like useful service life of this product? Thank you.
Well, thank you very much. For the first question, the main advantage of these geocomposites is it is mainly made from polymeric materials, mainly polypropylene, if not HDPE, or high-density polyethylene. So these materials are very much inert to any chemicals or any other harmful elements. So this one will be durable in most of, if not all of the applications here in the UAE and other parts of the world, as long as there will be no high concentrations of petroleum products that can damage most of the some parts of the geosynthetics. But to answer your question, yes, they are fairly durable and are very much inert to most of the chemicals available on high aggressive soils. So with regards to the durability itself, it is found that in most of the testings and most of the durability testings that we have done on our materials also, we can assure that it will last more than 25 years, and some are even durable up to 100 years of applications. So if you are asking for durability, these geosynthetics, not just geocomposites, not just drainage geocomposites, are used or highly used in landfills where there is high concentration of leachates, high concentration of harmful elements that needs to be contained not just for 25 years but more than 100 years. So these materials have already been used and is successfully been addressed, that has successfully addressed these durability concerns in most of these applications.